Yeah. When I created, and then the recent calendar sort of picks up events in case you want to attend or something like that. Yeah.
I think it's because it's a new, before we didn't have the Zoom thing, like the tab, so we could go on it, so that go directly to the system as well.
Yeah, yeah.
So yeah, it makes sense. It's on Zoom. That, I don't know.
Yeah, no.
Because Martinez is also trying to,
Oh,
she shared an office with Liskis, so.
Oh, shit.
Well, they had their own offices. which is
Yeah.
like older.
Yeah, the drops are
I don't know,
she might just be safe, take the class.
might talk to her now.
I don't know. we have-
Was it Martinez? It's right here. Oh my God.
no, next
I don't mind. I haven't opened my email yet, but. Yeah.
But now she's calling.
So what's this in trouble? There's one at 11. I'm gonna be exposed to the voice now. She looks up.
She could be left home alone.
Yeah. I mean, what do you think?
That's happened now.
Now, for the first time.
Yeah.
That was just a scare.
When I was younger, my sister was 14, like when I was 11. Looking for my sister was 14. Did she act like a 14-year-old? No. So I was like, okay, here's dinner at 12 for 2 hours. Do something. Did homework like that. What else I learned here was to do.
Hi, guys, good morning.
Watch the water.
I insist on being 1 minute late, even though I pressed that. So we're almost done with wildlife management for some reason. So the idea is that there's just several ways to tackle the issue. You know that because the kind of comprehensive. So there's no wildlife because no what management involved. Public opinion. So within the science, of course, there's what we can call the wildlife ecology. You can do ecology for the rest of your life, you don't have to manage. So there are definitely within a much larger group, I keep referring to meetings, multi-partner meetings where you sit down and law enforcement. These are also governmental, non-governmental also good. You see, the list can be very long. I don't want them all because they are. So with, so within the, I mean, I could spend a lot of time on the science part of it. I want you to get something excluded from this class, because a lot of animal ecology, Richard, anybody just who are taking animal ecology. So you see, I could be using all that stuff over and over, right? So, Richard, maybe anybody heard of habitat selection within that class in animal ecology? There's detailed concepts on habitat selection that are very important that I haven't covered. Jumping right into the landscape, thinking, oh, this is habitat. All good. Black hat from the screen saying habitat. Whoa. So there's habitat selection processes that makes it a habitat. The animal has a choices. Selection. So I can't help it. I'm going to put it to the final exam. Maybe next class I'll come up with just something I this morning thinking I talked about the habitat itself. We keep referring to habitat matrix, landscape, and all right, which is very important. But with it, you gotta know for the exam that look for the habitat itself as qualification. We talked about habitat suitability, which is broad pre-assessment, I'm going to call it. You haven't put an animal yet. You can look at a bird and determine if it's habitat suitable for koala. So habitat suitability is just whether there's animals or not. You look at a landscape and then, habitat, and you determine whether it's suitable. Of course, hopefully there's animals there that confirm that it is suitable. But when you look at the animal perspective, that's when you get into habitat selection. And I'm just warming you up to a couple of slides I'll put up next class, but I didn't think them, but I'm going to extract some classic work and statements on the selection probably depends on the so you understand that the animal has a choice. You think of a dispersing animal. When you talk about habitat selection, you're thinking of an animal that is about to make a selection. You can't, well, I was gonna say you can't make a selection. Or Amazon. You have to go to Walmart, you have to go out there. So typically habitat selection happens when animals have to pick a habitat. If it has an established habitat, what do you call that? Anybody? And you've got an animal that's living there. What do you call it? The area. Home rate is simple enough for sure. All right. So of course we talk about linear for me. Area for most animals that are cursorial. And 3D for an animal that moves vertically, for example. Kind of feeds and kind of forest flora, other. So that's the home range. Everybody assumes that the animal that's there reproduces, has its fitness, therefore it's suitable, and therefore it encompasses every need of the animal. The needs are very simple, of course, you know that. You would start in order to accomplish your fitness, what do you need? To survive. What's the primary thing for surviving? Anybody wants to survive. We need every day for survival.
Mhm.
Food is energy for sure, yeah, absolutely. First things first. So feeding ecology, you can imagine, is a primary concern to any kind of animal. Except the dormant previous season blueberries. Okay, so so food and then reproducing, so definitely an animal alone doesn't do it, so we can talk about mates, sexual partners involved. These two make home range. Woman male that doesn't know of a female somewhere that he, when she's ready, that he will mate with. Otherwise, he's dispersing. So back to habitat selection. So this an animal that has a home range. Did I say established? Yes, established home range. It's redundant. Every paper will say home range, meaning I know it's circular and it goes around and it doesn't move out and it doesn't. There's variations, but still you direct a core area. Some animals very easy when you have a depth. So what we're talking about here is habitat selection. Back to habitat selection. There's no habitat selection in established home range except with the animal defined as perfect. Well, it doesn't have to fit. It's fit already, correct? That's what we're talking about. So habitat selection is when you have a choice. Try to write down two terms. Habitat preference is when you have choice between two systems, for example. Preferences. The paper will talk about two options. Habitat selection, we got 60. Making it big, of course, you know, it could be 5, 4, 6. Selection. So in terms of science, it makes a bit of a difference. In terms of stats, it makes a bit of a difference. You can imagine that if you have only choice between forest and ocean, your stats are going to be binary, pretty simple, right? But habitat selection requires more modeling just because you have to account for different uses for depending on. So you've seen that already, and write it down if you want to refer to previous material. Forest ecosystem classification, FEC. Beware. Drop feels like this course has lots of acronyms. You guys look at make a list of acronyms somewhere on the side because country can't help it. So FEC is being used for forest ecosystem classification. And in there, the market has a choice between 22 classes, 22 types. So you're talking about that selection pathway. So the analyses are obviously multidimensional and somewhat iffier. You know, like between two habitats easy, like, don't like, but between 22 classes, more birch, less birch, more humid, less humid, and so on. Tricky. I don't, I'm just going through the concepts, really to go into any kind of multi-dimensional, multi-scaling approach, we would need a good 2-3 weeks of possibly simulations online just to understand the weight, you know, the weighing of these parameters versus others. and definitely not something I published before, so I don't know all the mechanics. So let's go back. So my little warm up so far was a long one. Was warming up to the concept of habitat selection. Landscape, there's habitats and there's nature. So all that little bracket made is all the processes that say, okay, there's food that nobody's looking into the habitat. Like, right, I said that. So I'm sorry if the material is a bit disorganized, just thought I couldn't leave you without in this class talking about this, the concept of, well, we're talking habitat. But I started this class thinking, oh, I gotta swing them into the landscape ecology simply because this is coming next. So if you want the job at the interview, I suggest you put in the word landscape ecology. That's as simple as that. It's not extremely complicated. It's just, I think it has to do more with geometry. So we're leaving the wildlife behind, whether it's a moose or a mouse, I'm looking at. If the patch is black, it's not. If it's white, it is matrix. Of course, just that, thinking, let's look into the principles of it. What does matter in its shape, size, and so on. So of course, we've gone through many of the parameters, and this is based on Farrig 2003. I repeat what I said last class in Porter et al. 2021, the book you should have, right? And then, you know, he said that most of you don't have the book, the monograph, but we'll see. I'm putting as much as I can on PowerPoint, but I'm referring to chapters 4 to 4 to 9 and 10 to 14. So, but I'm extracting material. I hope it's going to be enough for you guys. We'll see how that goes. No matter what, you will have spent lots of contact hours talking about wildlife management. So I'm not shy. You know, if we had to cut this short today, wouldn't be a problem. We've talked about landscape ecology already. We have some charts already, so not too bad. So, of course, because it's a sort of a kind of worms, if you see landscape ecology, landscape ecology. So there's details behind it. That's the idea of spending time on it. So we've seen these already. We've seen this already, and this is what I take out of it is that there's a whole bunch of parameters right away. I don't see the word moose or mouse anywhere, right? So the wildlife is somewhere else. There's that habitat is broken down somewhere. So those parameters are really important, and that opens your eyes on 12 fragmentation variables. You can imagine how many measurements you need if you're going to do it. So obviously, we're the whole, I'm going to say, knowledge. The principles are pretty well established now in 2021 with that kind of book, which it just came out, where a whole bunch of specialists from all kinds of different states show their how it applies to winners. The concepts are set down. It's you guys to apply those concepts to real cases. Not always doable. So I warn you right away that if you want the job, if you want a simpler job, if you want to work only 40 hours when you're paid only 40 hours, and not work 65 on the weekend. Try to pick habitats that are simple. So I say corn versus wheat, good start. All right, and we're talking several measurements. We're talking Jerry. Here we go again. So let's imagine there's no alleys in this room and it just says, should I put my new road in the field? Should I put it here or should I put it over there? How many roads can I put? And so on. You're gonna say, well, it looks like you're fragmenting the habitat, the block that you have, right? So it's all about fragmentation, but there's 1,000 ways to fragment. This is why you need so many measurements, because the minute that you put somewhere, you divide the habitat, that's what, right? For the exam fragmentation, divide, very important to realize that it's separate from blocks. We'll see where that goes. I hope these are clear for everyone else, sorry. That's not clear to me, so I hope it's clear to you. Kidding. So remember that I put those items in the same order, so we can extract our table like this, just very boring. Simply, as I said, meta-analysis of collection of papers. Fairly recent. And looking at what they used and what they measured. So these are the possible effects right here, and this is the response right here from the organisms right here. And the way I looked at it, I'm thinking, well, it looks like measuring abundance is easier than this one, population growth, and that's what I want to see. So my question, another simple way of asking a question is, I know, why are there only 3 papers on population growth and patch size, as opposed to, say, 26 on the top left? Just everyone, right? Is that there's more funding, or for the same funding, it's easier to measure abundance and patch size? So, because I'm a wildlife ecologist, I'm interested to see exactly what kind of labor I'm getting to. So abundance is just a count. I'm over here. And then the richness is a number of species. You know that already, correct? It says also diversity. You remember the difference between the two, anybody? Let's go ahead and call. Come on. Come. Do it. What's the difference between richness and diversity? Anybody? Good. Cover this. Yeah. Corresponding like
Diversity is the amount of different individual species in an area, and as an richness, the overall abundance.
Yeah, it's getting there. So richness is a count of species that I find in a given area. So a count, a full count. One is a good count, that means only one species. 5 is 5 species spread, or 5. That's a richness. Everybody agrees that it's okay. It's pretty simple, right? So it's like you're doing bird ecology. All you guys have checklist. All right. Diversity accounts for the proportions of each within the group of 5, say, richness of 5. Yeah, the diversity depends. That's all you need to know for now. Depends on the proportions of each. So the measure becomes a little different. I think you have to know how many there are of each proportion. So 10% margin, 30% margin. All right. Up to 100%. So out of 100%, what is the dominance of it? Intuitively, since we're here, something I want to say at the final, but intuitively means that you've got more diversity in, and this is mathematical and an index. If your proportions are more equal, in other words, if your community is even. Like in, and therefore your diversity will. That means that principle is pretty simple. So diversity accounts for a index of the amount of genes present. So again, just quickly, if I have a community of 5 species, richness is 5. But if the proportion of one of them or 2 of them is extremely rare, think of ginseng, something very rare, it won't increase your Shannon index, therefore the diversity is not increased by the additional rare species. It is well represented species in your community. All right. Of course, we all know Amazon forest cheats a bit because it's not adding 2 or 3 rare species. It's adding like 2,000 unknown species yet to this thing. So good luck. All right. So again, this is the way I'm discussing it. I'm thinking as we go down the list, I'm on the response because I prefer it because I'm more of an ecologist myself than a landscape ecologist, but really, I know abundance will be straightforward. First things first, on the Monday morning, you sample, first thing you want to know is how many there are. So abundant density, very common. Richness, diversity, keep in mind that richness, diversity means you have to see all of the species, right? So a little more complicated, just moves. All right. Presence, absence, pretty easy. Fitness measure, we talked about this, for example, fat reserves, or it could be all time. Genetic variability means you need blood sample. Whoops, you're gonna stay on Friday night, I think. Species interactions mean you have to observe two or more species, not simple. Monitor, follow, track 2 or more different species, so a little heavier for field work. Extinction, you have to stick around long enough. Turnover, so you have to come back every 5 years in the population and take blood samples. Well, you're gonna stick around for a while, better keep the job. Individual habitat use means you got a radio collar, for example, right here, very detailed on habitat within the home range, and then same for movement dispersal is health, because you have to locate the adult. Radio collar finds it then, count the young, and see where they're going. Dispersal. And population growth, well, you're gonna be there 30 years. Same idea. All right. So for life tables, I mean, on animals that are very long lived, it's quite difficult. Within those right here, same principle applies. So in that table is that the first item should be simpler. The first things first. Patch size is an easy one because your habitat ecology go right to moose habitat to measure the habitat patch. Habitat loss is not simple, but it works well with the logging, for example. So when you're thinking short term, in October you got forest, in November there's no more. So your habitat loss is pretty common. So it can be done short term. There's cases where it takes a little longer. For example, if you're looking at the forest north of the Sahara, called desertification. So the forest is receding in the north. And, that's going to take 20 years before you measure anything. But otherwise, habitat loss is very common in the literature. That's what it says right here. Patch isolation, you're into moose habitat. Come on, you want to know at least outside of it and see where the next patch. So patch isolation. Write down right away the term nearest neighbor. Something extremely common. The edge is not especially easy, but it's a bit complicated. The edge is important. You'll have to keep in mind for the exam the edge is neither habitat or matrix. It's an interface. And again, I mean, I mentioned that several times, contact towers, guys, that's your phone. What do we call an edge that is gradual? So instead of, this is an edge right here, so I got habitat, I got matrix, unsuitable for a laptop, very suitable for a laptop. That's an edge. No question that the laptop will drop right away. What if there is a bit of a slope before it falls? What do you call that? In ecology, change between gradual change between two habitat, two ecosystems. No, succession is temporal, so over time. I'm talking spatially. A field that goes into the forest, forest that goes into the field, and you got a width. Neither habitat, not forest, and it's not field, what you call it, the transition. That's right. You got them all. You got all that. Mr. Callan, maybe. No. Ecotone. Ecotone. So that's I'm mixing in the principles with the real life. So there's many habitats where the edge is actually a ecotone. The edge is sort of simple in landscape ecology. They can only deal with an edge because it cuts right there, so you can really measure. When you're out in the field and you measure, say, am I still in the forest? Not sure, Jerry. Keep walking. Am I in the field? Yeah, I'm not sure, Jerry. So there's a whole thing where you question yourself on habitat suitability and so on. So I just made open another question on edge. So for the final exam, that's a question. Discuss the question of edge. I said, I'll repeat. Edge is not habitat, edge is not matrix. It can be sharp as an edge, and it can be gradual as an ecotone. So no matter what, whether edge, because I mean, if I could even put in the question, say, we're don't freak out, don't pass out. Yeah, I mean, whether it's a net or an ecotone, so I just refine your concept of that edge they're talking about. No matter what, it might have a positive or a negative effect. So in other words, there's some animals that consider not only the habitat they're in, but how close or how far they are from an edge, which will represent the end of their habitat, correct? So the same for this wonderful lady is really hugging her laptop real good. I don't think she wants to use this right here. It's not favorable for the laptop. Everybody sees that? Right? Same for moose possibly, but it should be the other way around. So the moose is a good example of an animal that likes the edge. So not to live there, it won't, I don't think it's spawn there, it's a calf, I should say. But it needs edge. Oh, so I found something neither. Now, edge has to apply to something, so it's not the edge of the matrix or focusing on, we're looking at edge of habitat, at least there's habitat behind. All right, so it is linked to habitat, but it's only a feature of habitat. It's not a home range. So, there's some animals that are, you want any examples? Anybody can think of animals that really like the edges? And I'll keep it simple, not ecotone is complicated. Edge, sharp, what likes the edge? A crab would answer. So a crab has to sit right there. Not too deep. Not too shallow. Right there. literal at that scale, of course. If you've ever done some boating on a river anywhere with the power boat like that. 5 horsepower, 10 horsepower, 15 horsepower, something not too fast. And suddenly you have a bird that follows you all the time on the river, and that's a kingfisher. So you got them local in there almost every river. They fish all day and they just like to race boats. Don't ask me why. Make the search proposal on that one. So another edge species, absolutely important that the edge is there. We're looking at a very sharp transition between forest, overhanging a river, absolutely critical. So, yeah. So edge comes early in the process right here, number 4. Number of patches is a more extensive, so somebody was lazy, they said, no, we're not gonna count patches, so. Connectivity is not so simple. Connectivity is not so simple, fewer papers on that. And of course, that means I need 2 points to start and an end somewhere. And of course, I need to write down the word network. We've seen it in a paper on salamanders where this guy was creating a new pond to one pond. There's only a connectivity. It's not simple because it's a network. And what you want in the end for connectivity is really gene flow. So if you're sending your moves out there to die, right? So connectivity has to be measured over several, a good time of the lifespan of the animal so that you can actually measure the gene flow. So we take blood samples in each area and see whether animals transition. Animals is good for most ecologists because you can't do DNA all the time, although it's getting there. But otherwise, at least you say, well, at least this animal moved in, and I moved in and survived. All right. Even better, reproduced. So that would be connectivity right here. But a little harder to measure matrix quality. That's almost secondary to most people. You focus on the moose, focus on the habitat. You don't want to know how unfavorable the matrix is, but sometimes. And right when we send these thinking of a perfect example. These things send. I could read your mind from here, Yeah, so you're looking at, raise your hand, Algonquin Park, anybody? Algonquin Park? Hey, boy. Well, the oldest park in the country, right? And a very large one relative to others. So extremely large. So in terms of sustainability, it makes it easier. Because Algonquin Park makes a habitat because it's uniform across, meaning, it's a park, it's only canoes, the next walk back will look and see, hey, what's this? It's another canoe, don't worry, Jerry. So it's peaceful, it's a park, one piece, beautiful. What's around it? Well, north, you've got the Highway 17. Right down the road, Martelli Matrix, just lost a few points. So road on the north. And then what else? How about the Hunters to the north? Whoa. Roads, we can't do much about it, right? There's only one highway across the country, not keep it. Maybe if we could, we'd make a bridge. Why isn't there a wildlife overpass over the 17 west going to Ottawa? It's because the other side of the bridge would send the animals straight to the Ottawa River. Whoa, landscape ecology. So north of Algonquin Park, there's a barrier with the Ottawa River. Barrier, it's open. And the Highway 17 is on very well. So the matrix to the north, not the best. I don't think Algonquin is receiving new wolves from So matrix unfavorable to the car, you know. Okay, so you have to look at every side of it. And then I said hunting. So suddenly there's something we can do about it. We're not moving the auto worker, we're not moving the highways, so how about moving hunters? And that's what's happening right now. Wildlife ecologists in Algonquin Park have been monitoring the wolf, which is an apex predator. You can keep wolf, keep tourists alive. So it intensely managed, monitored, and so on to know exactly how many tags there are. I'm not sure. For years, they allowed hunting around the park. Big debate. Hunters said, "Come on, I get $120 per kill, this and that. Wolves are getting into my backyard, whatever excuse they'll find, and they want to be allowed to take some wolf, so they have." And now I think they just reversed power, so that's the politics, but essentially I'm saying the matrix counts. This is what we're talking about, matrix quality. So you have to be around for a little while to know about matrix quality, because of course it's some more to measure. You focus on the habitat, oh, Algonquin Park, beautiful. Whoa, what's around it? What saves Algonquin Park is probably that with its size, each habitat is surrounded by habitat. Unfortunately, landscape ecology doesn't recognize that. The patch is very big. So patch size again is the main feature I say in the example I just took of Algonquin Park, which is just became material for the final report. So matrix quality pretty interesting, but more work. Patch shape is complicated because we're looking at geometry. And you could be looking at all kinds of patch shapes. So really, this is still in the infancy. People are still modeling, say, oh, what if I make a rectangle? What if I make a square? So you understand, getting you, of course, into the geometry part of the landscape. Qualitative, thank God, not too many. Patch scale should be plural, because if you say patch scales, because you measure more than one scale, it's always called scale. Let me study Sudbury, say, whoa, I gotta study Northern Ontario to see what Sudbury is setting in. So patch scale. What's a good black bear habitat? Oh yeah, Sudbury, good answer. Yeah, black bear. Why? Because blueberries, good answer. And because of fire regime and so on. So blueberries is around acidic soil, the Cambrian rock, everything's there for blueberries. So that's a habitat, that's a huge habitat. And what's the matrix like? There's more bear habitat. See how complicated this gets? You gotta be at Moosonee in order to stop seeing black bear. Bad example of a habitat selection. And it's a habitat generalist. So that becomes really complicated. So that's patch scales. Landscape scale is complicated as well. And then patch and landscape have been considered as well. So in this picture right here, does the process of that fragmentation. I'm not sure why this paper, 2003, very again, I gotta say, this is the same as chapter 7 of the textbook. So the North Ferry is on a quarter of the chapter 7 textbook. I've been using her thing because I mean she basically redesigned chapter 7. This, she's definitely an authority in landscape ecology and biomathematics. In this figure 1, she's talking about the process of habitat fragmentation. And sure enough, I recognize the breaking down of pieces. The thing is, it overlaps with another feature, which is the point of her paper, which is habitat loss. So quite easy questions for the exam. What is FARIC 2003 referring to? Get used to author names, by the way. We don't have 100. Get used to author names, so it could be in the question. FARIC 2003. And she's trying to, her take home will be that habitat loss should be mixed in with habitat fragmentation. So obviously she's trying to make a distinction between the two. In this example, figure 1, she's actually showing both overlap. So this is a very real case where this is typical habitat ecology work. And say, oh, here we just cut down some more forest. If you go and measure what's left, right? So we're talking habitat loss. This is super record. That's because we're an invasive species. So basically we take over many habitats. And it's a gradual progressive. In the valley, I used to take my ATV across the field, and now it's a new development gone. So matrix probably unsuitable for my ATV. So in this case, it's an overlap. Figure 1 is an overlap between the two. Obviously, you realize that if that was 100% habitat, this is not 100% habitat. There was habitat loss and there was fragmentation. How do I know there's fragmentation? Because I go from one piece to more pieces. One piece, and I got 1, 2, 3, 4 in this case, and more in this one. So this is very common, extremely common. So I think the whole paper is about the wording. They want you to be careful next time you talk about, oh, stop fragmenting the habitat and so on. It's not about fragmenting, that's the problem. It's the fact that overall the percentage went down, habitat loss. So this figure is pretty poor, I'm gonna say. I can only so. This shows a couple of scenarios. I see 5 of them where different scenarios from initial point times 0 right here. And FARIC just played around with the blocks and obviously removed some right here. So the number of patches went down, not good in terms of habitat. That's called habitat loss, right? Number of patches went down. Not necessarily, though, it depends on the patch size, but in this case, patch size hasn't changed at all. That's the mean patch size right here. So let's analyze in detail what happened here. I see that Jerry somewhere decided to remove this woodlot. Think of it as a field where there's woodlot, for example, something like that. And also decided, whoop, Freddie also decided to remove this one as well. So a number of patches went down. The patch size has remained unchanged, and the degree of isolation went up. So in this next scenario right here, let's see. So this long patch right here was cut. So somebody drove a road, a gravel road somewhere overnight right here. And so in terms of habitat loss, I mean, number of patches went up simply because you broke 1 and 2, right? So that's typical fragmentation, number of patches. But the mean patch size went down, but look, you're creating some connectivity here. This case right here, number of patches went down. The patch size went up because I removed only the 2 small ones. So average patch size good. And then no change in isolation. So it goes on like this. And of course, the idea is that habitat loss results only in some of the 3 expected effects that are right here. So habitat loss is supposed to increase the number of patches. And it's not necessarily the case right here. So for example, number of patches went down. All right. so bring that to the exam. So expected effects of habitat loss, increase of number of patches. Decrease in patch size, you're taking away some habitat, your patch size, you would expect it to go down. And patches should become more isolated. So this is the big scare. Time you see paper that says habitat loss. Because you think in the back of your mind that number of patches will increase, so will patches into one big one. That patch sizes might come down as well. And that you have more isolated from the next. All right, again, I could go back to this model right here where you have absolutely just one patch, one big patch, there's no isolation measure. The amount of bed is very small. Look at the amount of bed on this one, these ones. So this is important as well for the exam. These, I mean, the best way to summarize this is, of course, showing what say habitat E. About that. Also, that the graphs are showing habitat amount from 0 to 100. So I read left to right. I don't know what you do. But to me, that looks like a game right here. So obviously, I have to start reading each graph to the right to the left to see. This is based on richness of species. So the patterns are very different from one. I'm going to say one feature of the habitat. This says right here, number of patches right here. So again, my tendency would be say, oh, look at that. You know, I mean, as I go from a vacant land, I build habitat, and at some point there won't be room for more patches. The number of patches will stabilize and I won't increase. At some point, if I got 90% of my landscape covered, I think we'll have the power of not increase number of patches. So this is one way of looking at it. You're not memorizing the patterns because this is just textbook material you can refer to all the time. And it's not the only measurement you would take in the field. But certainly that figure shows that each feature has a very different meaning pattern. The closest to it is total ledge. Woof. Right here. Closest to this one, bell curve. Total ledge, and again, my simple mind, I'd rather look at habitat loss. So really, I want to read these graphs backward. So in other words, I'm into, let's say, yeah, let's say that I'm starting with Algonquin Park right here. And then I let loggers come in and they take some of the habitat down, say to 50% of it. This is when I should have the total ledge, the maximum total ledge right here. Eventually, if I reduce the patch sizes, small, right? So that's why I have this bell curve. So these two are like the same to habitat loss. Let's look at this one right here. So this one's pretty seems pretty simple. Mean patch size. So it's just mathematical because it's an average of the patches, whether you cut here and here or whether you cut all here. Average patch size will just be proportional to habitat loss. Of course, that one you just took some of the habitat, each patch on average will get some loss. This one right here is showing the nearest neighbor distance. So the statistically tends to be only at the very, the very low amounts of habitat, at 20% and less. That suddenly you start seeing a whole bunch of distance. It's called what again? Isolation. So this is pretty important to realize is that the isolation will come in only, and that's statistically, if you cut through the landscape. It's only when you cut more than 80%, I'm gonna say, 3/4 of the population, that you start seeing isolation. And this is size of the largest patch. I'm not covering this one simply because I'm not exactly sure the details. And notice that this is these are all patches. So again, if Sudbury is continuous habitat for blueberry. You don't know what's happening until you go to the landscape. So you have to go beyond the habitat. Yeah, for black bear, pure health. Go to that's a big. So we're almost done for this morning, guys. Very tough. Going through that paper again, figure 4, just showing that you can get 2 different trends depending if you're looking at the right scale. Scale is very important. Landscape scale, landscape ecology. Scale, and by definition, means you have to be able to recognize patches separated by matrix. So patch scale study right here is showing it's measuring, what do I see here? Population density. And if you look at patch scale, of course, you know, way more flag squirrels here, a little less, fewer here, and then the least would be right here. And this gives you a relationship between patch size and the abundance in this case. Decreasing or big reservation, you reduce the habitats and you got less population, yeah, for sure. But in the landscape scale study right here, you tend to show instead that population density in the landscape is positive because this poor fellow right here, which is right here, right, is surrounded by favorable stuff. In the landscape, there's more habitat that can provide a positive relationship between habitat amount and abundance. Very big difference. So you might feel sad for that little guy, but if he's surrounded by a good landscape, therefore the relationship might be positive. So in this last one, I'm stopping here. I said I was going to stop. Figure 5. So both loss and fragmentation are in smaller patches for sure. So that's never good news. So fragmentation not guaranteed only if the species will benefit from it. But the opposite of that, what we call this center of the forest, you know, for a forest animal. In a patch like this one, any of those patches, this one. So what do you go? The edge is fine, it's surrounding the perimeter, but what's inside, what do you call at the exam, what do you call that? Core is good, center is good, core or center. They use the same thing for a core home range, for example. So core home range is center of activity. So it's a decision maker. I once worked on tracking animals, smoke tracking animals, and we always wonder, okay, I'm leaving the truck here. When do I start? When am I to mark the habitat? So we have to walk 100 meters before we thought we were far away from the edge. So, and I'm referring now to the core area, which is the absolute safest, the most representative. So 10 meters from the road. All right. So, patch size is an ambiguous measure of habitat or fragmentation, So we don't know. But in this case right here, this is a habitat fragmentation. So I'm gonna leave you with this. I'm gonna stop right here. So fragmentation, we know is a divide. Otherwise, you're allowed keeping, how do you break down? Say, I'm gonna say forest. How do you break down forest? Don't put park, how do you break it down. From one piece to two pieces without habitat loss. Any. Hey,
Build a wall.
build a wall, and that's a pretty good idea, yeah, barrier of some sort, but, yeah, you're right, it would have to be a line of some sort, but otherwise, my point is, it's very rare. It's very rare, when you have fragmentation, when people say, we fragmented the northern forest, this and that, it's obviously because of loss, am I right about this? So there was some kind of a harvest of transit, a transformation of the matrix. Building a road. That's my take home for today. The only way you can fragment only. The only way you can fragment only is if you cut. My solution for generating good answer. Generating new habitat. So Dr. Farid from Carleton University is a cheater. She started from this right here and suddenly she put fragmentation. It looks very nice. It's only a divide, but actually she kept the habitat amount. She added some magic. She started playing. Oh, cheater. So in most papers, this is not what's happening in real life. You're losing habitat and it happens to be fragmented, which adds to the problem. We'll get back to that next class. Thank you very much.
That's why.